So this is an interesting problem where they ask you to use your knowledge about the reactions of organic molecules that we have seen in this chapter to find out what kind of visual test that you can use to distinguish compounds from one another that are given in pairs here. The first is phenol and anisole. So phenol, as we know, is a benzene ring with a OH group, and anisole is the same except you now have an ether as opposed to an OH group. So the best way to distinguish between these two is try to dissolve this in aqueous sodium hydroxide solution. So if you take a test tube and you add the phenol into aqueous sodium hydroxide, the phenol will be converted to the phenoxide ion like the one we have seen in the lab. In fact, you guys did a lab with this. So phenoxide ion, being an ionic compound, is going to dissolve completely and very easily in even dilute aqueous sodium hydroxide solution, whereas the ether is not going to dissolve at all, and it will stay out as a clear insoluble compound or insoluble droplets, and if it's in the solid form, it will remain insoluble as a solid in aqueous sodium hydroxide. So this will dissolve and completely be miscible in water. This will not, which is going to give you a visual indication about what kind of molecule you have. So that is the first one. So this will dissolve into a clear solution, this will not. 1-butanol and methyl propyl ether. So butanol is a 4-carbon alcohol, and methyl propyl ether is an isomer of butanol, which is this. So both of them have the same molecular formula, which is C4H10O. But one of them is an alcohol, the other is an ether. So what visual test can we use to distinguish between the two? There are several tests that we can do. The first thing is solubility in water. So if we take again a test tube and if we add a small amount, so let's take for example if we have 10 ml of water in it, and if we add a drop of the butanol, the butanol is going to dissolve in water because it is able to hydrogen bond, right? Because it can hydrogen bond with the oxygen in water, making it soluble fairly well, because we have seen in the classroom that isopropanol is very well soluble in water, but once you have an extra carbon, it's not going to be as soluble as isopropanol, but still it is going to be soluble in really small quantities. So if you take 10 ml of water, add a drop of butanol and mix it well, it will dissolve, especially if the water is warm or hot. Whereas ether is not able to dissolve as easily as butanol in water at the same proportion. Therefore, this can serve as a visual indication for the difference between an alcohol and an ether. That's the first one. Now another difference, so this is not going to be soluble. It will float on the top. The second example, which is probably a little bit more clear indication, is if we take an alcohol like butanol and if we add sodium metal to this, not sodium ion, sodium metal to this, you will see, based on the reaction we have seen in the classroom, that this is going to produce a sodium butoxide, and this is also going to give you hydrogen gas. So you're going to have equivalence in terms of stoichiometry. Nonetheless, it's a hydrogen gas, and you can see hydrogen gas bubbling out of the reaction medium, especially from the sodium metal chunk when it is trying to float to the bottom or sink to the bottom. So that hydrogen gas release is going to be a clear indication of the presence of an acidic hydrogen from the alcohol, whereas the same reaction is not going to be possible for ether, because ether does not have an acidic hydrogen like this hydrogen, and therefore there will be no reaction or no release of hydrogen gas from the ether. And the third example that I would say is butanol is going to have a much higher boiling point than ether. So if you take a butanol and you heat it, it's going to boil at a higher temperature than water, it's going to have a higher boiling point, more than 100 degrees, whereas methyl propyl ether is going to have a much lower boiling point, which can serve as an indicator for the difference between the two substances. dipropyl ether and hexane. So dipropyl ether and hexane. So the difference between these two is that if you take a dipropyl ether and add it to water, it's not going to dissolve, and you take hexane and add it to water, it's not going to dissolve. In both cases they will separate out as a thin film of the solvent you just added, of the liquid you just added. So if it's water, water is going to stay at the bottom, and if you have a few drops of the dipropyl ether, it will float on the top. Again, in a separate test tube, if you take water and you add a few drops of hexane, the hexane is also going to float on the top, because they are both less dense than water. So there is no difference here as of now. But if you add a small amount of concentrated sulfuric acid to this in water, so if you have the medium which is fairly acidic, then the ether is going to dissolve in water at that concentration of acid, whereas hexane is not going to dissolve in water no matter what. And the reason why ether will dissolve in water is because in acidic medium is because by itself ether is fairly nonpolar, but once you add a significant amount of acid, the acid is going to protonate the oxygen, making it an oxonium, and now this becomes a ionic compound, and therefore it will be able to dissolve in water when you have high concentrations of acid. So that solubility in the presence of acid will show that you have an ether. The solubility in the presence of and the lack of solubility in the presence of good amount of acid is going to show that the hexane that you have hexane in your hand. Okay. Ethyl phenyl ether and allyl phenyl ether. So they are both ethers here. So this is phenyl ether, so ethyl phenyl ether, and you have allyl phenyl ether, which is that. Okay. So here you have a 2-carbon chain which is saturated. Here you have a 3-carbon chain which is unsaturated. On the other hand, you have phenyl on both these ethers. So bromine, when you have acetic acid, is going to undergo discoloration because you are able to brominate the ring. But in the absence of acetic acid, if you just have bromine in dichloromethane, which is not an acidic medium, then the bromine will not be able to brominate the ring. Br2 is not going to go after the ring. So what you saw in the lab when you did the aromatic chemistry was bromine and acetic acid. So when you have bromine and acetic acid, you cannot distinguish between these two. But when you have bromine in dichloromethane, then this bromine is not going to react with the aromatic ring, and the bromine is now going to react only with the double bond here, and this compound does not have the double bond that the bromine can react with. So Br2 with allyl phenyl ether is going to give you a dibromo derivative of the alkene, a dibromo product of the alkene, whereas this is not going to give any product, so no reaction. Therefore here Br2 is going to undergo discoloration, here Br2 is not going to undergo discoloration. So that is a difference between these two which you can use to identify which one is what visually.